Hey guys, so we're going to continue with our graphing trig functions, but now we're going to include some transformations. I'm looking at my handwriting right now that I wrote this up on before, and it's really terrible, so I apologize, but it says graphing sine, cosine, and tangent, including vertical displacements, which means a vertical shift up and down, and a phase shift, which is a horizontal shift, okay? So all those transformations that we did in the beginning of the year that you probably hate with a passion, those are going to come back. But don't worry, Kevin, we are not really, well, you already did the horizontal dilation by changing the period, so that hard piece is over with. All right, so if you remember, this is the transformation form of our trig function, and this sine could be replaced with cosine, with tangent, with secant, cosecant, everything works the same way, okay? So we talked about A being the, the amplitude, and also the reflection, So amplitude is really the vertical stretch, right? If you think about that, if you have a big amplitude, then your bars might be way up here and way down here. If you have a small amplitude, it might be right about there. So this amplitude is really the same idea as the vertical stretch. And then if the A value is positive / negative, we get the reflection. The B value here, which is always in front of X, so far we've just looked at ones that might say like 3 sine of 2x. This is the B value, whether or not there are parentheses, okay? So in our case today, we're going to see parentheses for the most part, but the B value is the same. And that is how you get your period, right? So that's really the horizontal dilation. And I guess above I should have said vertical stretch or compression. It's really the vertical dilation there. Doesn't just have to be a stretch. So B is the horizontal dilation, and we get that from our period, 2 pi over B for sine and cosine, or pi over B for tangent. So what that tells us is whether or not our sine function is regular, is compressed, so something like that, or is maybe stretched, something like that, okay? So those two values we've already worked on. Today, what we're going to do is talk about the inner parts, this x minus c. All right, c is what we call the phase shift, which is really just the horizontal shift. All right, and just like with any other of our functions, just like when we had a x minus h squared plus k, this piece in here, we use it to shift the graph left and right, and it's always the opposite sign. So if you see a negative value in here, minus c, it's really going to the right c spaces. If you see a plus c, it's really going to the left c spaces, okay? And then plus d on the end, again, just like we did with our regular transformation, similar to plus k. That is what we now call the vertical displacement. And really that's a vertical shift. This is going to give you a midline. So if you hear me talk about the midline, that comes from this plus d number. That's going to be the new center of our graph. If it's a positive value, the graph is going to go up. If it's a negative value, it's going to go down. Okay, so let's try a couple and see how it goes. So this is y equals sine x plus 2. So we're still going to find the same things that we found before. We want to know the amplitude, which would be the number in front of sine. If nothing's there, it's just a 1. The period is 2 pi over b because it's sine. And the b value here is, again, just 1 because there's nothing written. So 2 pi over 1 is 2 pi. All right. Before you draw in the amplitude, we want to take into account this final value here, this plus 2. Because it's outside of the parentheses, this is d, and so our midline is the equation y is equal to 2. So instead of our graph being centered on the x-axis here, it's going to be shifted up 2 spaces. So what I first want you to do is draw in a new midline. Actually, there we go, use the powers of notability. So that's my new midline at 2, okay? And then if the amplitude is 1, we have to go 1 space above that and 1 space below that for our amplitude. So this should be a distance of 1. And I'm going to draw in my amplitude bars just like we had done before. Hopefully you're better at making straight lines than I am. And then now there's no parentheses, so there's no phase shift. We haven't moved left or right. So we've set up where our graph should be, and if there's no phase shift, it's going to start at 0. We said our period is 2 pi, so let me chunk this into 4 parts. The last of those parts being 2 pi. All right, so label that 2 pi over here. And then halfway would be 1 pi, 3 pi over 2, just like your unit circle, pi over 2. Okay, those are technically here, right, on the x-axis, but I'm just labeling them up a little bit so that I can follow my graph. And then if it's sine, we always start in the center, right, and it's not negative, so I'm going to start in the center. At my next tick mark, I'm going to go up. Notice I'm not starting at the origin anymore, though, because this whole graph was shifted up 2 spaces. So I'm actually starting at the point 0, 2. Then I go up, middle, down, middle. So, oops. And there's my sine function that has a vertical displacement, or a vertical shift, up 2 spaces. Okay. So it's really that exact same sine function that we had graphed before. We're just bumping it up 2 spaces. All right. Let's try another. So this is y equals cosine of x minus pi. So let's go and find all of the appropriate values. Amplitude is 1. Period is 2 pi over b. B would be here, and if there's nothing there, we're assuming it's a 1, just like out in front. So it's again going to be 2 pi. There's nothing added onto the end, so there's no vertical shift. But inside here, we have x minus pi, and it's in the parentheses, meaning it's inside the function. So it's the cosine of x minus pi. Well, because it's a minus value, it's actually going to shift to the right pi spaces. Okay? So, when we go and set up this graph, I don't have to account for a vertical shift at all. So, this is still my midline. The amplitude is 1, so I'm going to go 1 space above, 1 space below. Draw in my boundaries. Okay, and then I want to label my x-axis. Okay, those amplitudes are not evenly spaced, and I apologize, but use your imagination here. So, oops, here's 0, and I am going to make some equally spaced values. 1, 2, 3, 4. All right, so the period is 2 pi, and we want to start at positive pi. So I want these to count in equal increments. So if the period is 2 pi, then if I divide that by 4, each space should be worth pi over 2. So, oops, I'm going to go in and label first off. So this is pi over 2. This is pi. This is 3 pi over 2. This is 2 pi. This is 5 pi over 2. 3 pi. And we could keep going if we needed to, okay? So because this says I'm going to shift to the right pi spaces, that means that instead of me starting at 0, I'm actually starting here at pi. So that is my first point. Okay. Well, technically it's cosine, so the top of my amplitude would be my first point. I'm not going to start in the center. So, but I'm not beginning my graph until here. And then if I count 4 equal spaces from there, I would end at 3 pi, right? So instead of this graph going from 0 to 2 pi, it's going to go from 1 pi to 3 pi, right? It should be the same distance between. It's just bumped over a space. So we're going to make the cosine curve start at pi, and then it has to end at 2 pi spaces later, which would be at 3 pi. So from pi to 3 pi is 2 pi spaces, which is our period. So cosine, I start at the top of my amplitude, then I go middle, bottom, middle, top, and I get my cosine curve. I could continue it to the left if I want. At pi over 2 would be in the center. At 0 it would be down. So you can see how that curve would just continue going. We're just starting it at a different spot. So really this function here with a phase shift looks like we started to draw a negative cosine graph. Okay, so a lot of these trig functions, because they're periodic, one graph can be written with multiple equations. So in this case, negative cosine x is the same as cosine of x minus pi. They give you the same graph, okay? All right, let's try one more that sort of combines a lot of these pieces here. So again, identify our values. Y equals 3 sine x plus pi minus 1. Amplitude is 3. Our period is 2 pi over b. And in this case, again, there's no number written in front of x, so it's just 2 pi over 1, or 2 pi. X plus pi means it's gone to the left pi spaces. It's always opposite of what you see in the parentheses. And then minus 1 tells me it's shifted down. Oh, that's not pen. Down 1. Okay, so my midline is y equals negative 1. So let's go to my graph here. Again, first thing you start with is your midline. If you have a midline change, you want to do that first. So our midline is at negative 1. So I'm going to redraw that in. That's going to be the focus for my graph, okay? The center piece. So now if the amplitude is 3, from negative 1, I have to go up 3 spaces. 1, 2, 3. And so the top of my amplitude is at 2. This is being vertically stretched. The bottom of my amplitude, if I go down 3 spaces, would be at negative 4. All right. And this time we want to label our graph in terms of, I'm going to have to make this go a little bit back here. We're going to label our graph with our period. So period's 2 pi. Then that tells me that each increment is going to be labeled as pi over 2. Right? 2 pi cut into fourths is pi over 2. So when I label this, we have pi over 2. I'm going to make that a little smaller here. Pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, I almost said 6 pi. And if we went to the left, this is 0, right? So this is negative pi over 2, negative pi. Okay? So, and think about those same tick marks should be on the red line, because that's what we're basing our graph off now, not the black x-axis. So because this graph had x plus pi, we should be shifting it to the left pi. So that means we're actually starting at negative pi. This is where the first point is going to go, but it's going to go on the midline, not on the black x-axis, right? This is the x-axis. So I'm starting at the center of this graph, but back at negative pi because that was our shift. And then the next point, because its sign is going to go up to the top of my amplitude. So at this next tick mark here, I'm going all the way to the top up to 2. At the next tick mark, which is 0, I'm going to go back to the middle. At the next tick mark, which is positive pi over 2, I'm going to go all the way down to the bottom of my amplitude and then back up to pi. And I could keep doing that. For as long as I wanted. And you can see we're getting a narrower version of our sine curve that has been vertically stretched, so it's taller. When we start to talk about sound waves and things that can be modeled with these trig functions, if you think about this amplitude here being really high, think about an amp in your car. The taller that function, the louder the sound is going to get, right? So we can model a lot of sound waves. We can talk about noise canceling headphones. We might do a little activity with that. All kinds of stuff that you can really do with these functions, and these different transformations play a role in that, okay? So this is how you really graph one with all those different components changed, and I know it gets a little tricky.